This is example 3 from your linear programming graphing worksheet. This is from worksheet 1. And the challenge with this problem is that there's so much going on, it's hard to know which variables to actually define. So we're going to start with our objective function first, just as your original note suggested, after we read the problem. So a baking tray of corn muffins takes 4 cups of milk and 3 cups of flour. A tray of bran muffins takes 2 cups of milk and 3 cups of flour. A baker has 16 cups of milk and 15 cups of flour. He makes $3 profit per tray of corn and $2 profit per tray of bran muffins. How many trays of each type of muffin should he bake to get maximum profit? Now, the key is in the question. How many trays, each type, maximum profit? So we're going to have to define P equals profit to write a P equals equation down here for our objective function. Now the profit is going to be $3 per tray of corn muffins. So we need to define our trays of corn muffins. So I'm going to make C equals number of trays of corn muffins. And then $2 per tray of bran muffins, I also need a variable for that. So B equals number of trays of bran muffins. Back down to here. $3 per tray of corn muffins, so 3 times C, which represents the number of trays of corn muffins, plus $2 times the number of trays of bran muffins, and that's represented by B, so 2B. Right, so we have our profit objective function. This is what we want to figure out. We want to figure out maximum profit. That's why it's called the objective function. It's our ultimate goal in the problem. Now constraints, those are the things that restrict us. And anytime you are baking, you have the restriction of your ingredients. So there are only 16 cups of milk and 15 cups of flour available to this baker. They cannot exceed the limits of their ingredients. Therefore, these are going to be used as part of your constraints. Also, we don't live in a world where you can make negative amounts of items of things. If it's a physical object that you're actually crafting or baking or in some other way creating, you are creating one of that item or part of one of that item. You're creating a positive number of that item. You can't make negative of that item. The only thing that I know of that you can actually make negative amounts of is money. All right, now writing these constraints. That means that B has to be greater than or equal to 0 and C has to be greater than or equal to 0. That constricts us, hence the term constraint. It constricts us to just the first quadrant. We are not going to go outside of this first quadrant. That's why it's important to write these down. Now for the rest of it, we have a certain amount of milk. So we should have one constraint dealing with the milk. And we have a certain amount of flour. Now you don't actually have to create separate variables for these because how much of this we can use is defined based on what we're creating. We have the corn muffins, and those use 4 cups of milk and 3 cups of flour. Now I'm writing out the word cups because I defined C as the number of trays of corn muffins, and C is our usual abbreviation for cups, and I don't want you to get confused in this problem. Could you use the abbreviations? Absolutely, as long as you haven't accidentally defined them as one of your variables. It makes things a little complicated. Right? And then bran, it's going to use 2 cups of milk and 3 cups of flour. So 2 cups of milk, 3 cups of flour. And the total that I have to work with, let me stretch this out a little bit more and write down my totals. I have only 6 cups of milk to use, and I only have 15 cups of flour. C is my trays of corn muffins, B is my trays of bran muffins, and now you can probably see how this is going to start to develop. And I wish I could move this over further, but as you can see from the little Star Trek thing here, I'm actually using a stack of DVDs to hold up my cell phone so I can create this for you. Tried to get my iPad Pro and Apple Pencil up and running, and sadly, my Apple Pencil is not working currently. Until my new one comes, we're stuck going kind of new school, old school combo. All right, so for my constraint for milk, 4 cups per tray of corn muffins, plus 2 cups per tray of bran muffins, has to be less than or equal to, so the amount of milk that I use has to be less than or equal to the amount of milk I actually have, which is the 16 cups. And then my constraint for flour, I'm using 3 cups per tray of corn muffins, and I'm using 3 cups per tray of bran muffins, but the total amount that I use has to be less than or equal to the amount that I have available in the cabinet, which is 15 cups. You cannot use more flour than actually exists available for you to use. All right, so now we have our constraints written. Now it's time to graph. So down here on my graph, I'm going to write corn down here along the X and bran along the Y. So for this case, my x-axis has now become my c-axis, and my y-axis has become my b-axis. Now I'm going to be going by ones all the way across here, so I'm going to count this out as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just to give myself a bit of a guide. All right, now my zeros here. That means that I'm looking at just this first quadrant. And now this one. When you're graphing an inequality or an equation that's in standard form, it's easiest to get the line portion of it by finding your intercepts. Now normally we call these x and y intercepts, but I'm going to call these c and b intercepts purely because those are the variables that I'm using. Now when you're finding your intercepts, you are actually finding, in this case since c is along my horizontal axis, I'd be finding the points, the value for c when b is equal to 0, because all along here on this axis I'm only moving left and right, I'm not moving up or down, which means that from 0, 0 it's only c that's changing. The second coordinate is staying at 0. That's why you know that b is equal to 0. Thus we put it into here. 2 times 0 is 0. That cancels out and you have 4c is equal to 16. I'm saying equal to because I'm actually figuring out how to graph the line, and the line is the equal to portion of this inequality. The shading is represented by the inequality part, the less than sign. So for the purposes of solving, I'm going to be saying equal to as I go through these. So I have 4c equal to 16. I need to divide by 4 on both sides. 16 divided by 4 gives me 4. And that means that my intercept for c is going to be 4, 0. Now to graph that point, I'm going to go down to here and count over 1, 2, 3, 4 and plot my point. Same thing for the other one. My vertical axis, only b is changing. If I am staying on this axis, this first coordinate has to say 0 for me to actually stay only going up and down, not moving left to right. So I have 0, comma, whatever my b value is going to be. And if I make c 0, 4 times 0 is 0. That eliminates. Now I have 2b equal to 16, divide by 2 on both sides, and then I have 8. So I'll have 8. Whoop, and I switch those around. 0, 8. Don't forget which one you were actually solving for. It's a common mistake, so common you just saw your teacher do it. All right, so 0, 8. Count up 1, 2, 3, 4, 5, 6, 7, 8. And now I'm going to connect those 2 points. Now, if like me, you don't have a straight edge at home, what I do is I'm going to use cardboard from a mostly used up notepad. So I just took the paper off of there so it doesn't obscure where my line is supposed to go. And I'm going to line this up as best I can where those intersections would have been. And there we go. And then I'm going to draw my line. And I'm not going to go past that, what is formerly the x-axis, the c-axis, because I'm staying in this first quadrant. So far I know I'm in this section. How do I know? Well, here's my little hack for graphing these. When I look at my vertical variable, in this case b, I look at the sign in front of it. It's a positive. That means that if I were to solve for b to get this into our equivalent of slope-intercept form, when I divide by the number in front of b, my inequality will not be changing. That means that looking in the vertical direction, less than is going down. Do you see where my pencil's ending up? Down, versus greater than, which would have been up, which would have been on the outside. So if I go down from this, all along here, I would actually be shading inside the triangle. That's how you graph these. That's how you figure out where the shading really goes. Now I'm going to worry about this one. So same thing again, 0 in place of b. That means 3 times b is 0. That cancels out. 3c equals 15. Again, I'm saying equals because I'm looking at the line itself, which is the equal to portion of this. And 15 divided by 3, that equals 5. So for my second one, I'm looking at 5, 0. And that means I'm going all the way over to here to 5. And then for my point starting with 0, notice that I started writing that first so that I don't forget. So I put 0 in place of c here. 3 times 0 is 0. That cancels out. And 3b equals 15. Divide by 3 on both sides. And b is going to equal 5. So I'm going to climb up to 5 here. And this one is going to... I'm giving myself a little bit of a guide, because it can be really difficult when you don't have a straight edge to get this directly on target. And since I noticed that both my intercepts were 5s, that means that I probably have a slope of 1. There we go. And again, because my 3b is positive, if I were to solve this for b to get this into slope-intercept form, I would not have to change my inequality symbol's direction because this is a positive. And when you divide by a positive on both sides, you don't change your inequality sign. So I would still be going less than, and less than would again be going downwards. Now, if I'm going to be less than for both of these, I'm going down from this one, I'm going down from this one. That puts me in this corner of the graph. And this right here is the point, let's see, 1, 2, 3, 1, 2, 3, 2, which means the vertices that I'm checking, let me scoot this over to here, are 0, 0, I'm checking 5, 0, 0, 5, and 3, 2. And if my profit equation is 3 times c plus 2b, then I'm looking at 3 for 0, 0. I'm looking at 3 times 0 plus 2 times 0 equals 0. That's not going to be it. For 5, 0, I'm looking at 3 times 5 plus 2 times 0 is equal to, see, this is 15 plus 0, which is 15. Ooh. And I just noticed a mistake that I made. How many of you guys have been yelling at me this whole time that my point was actually 4, 0? And yes, I'm going to leave this mistake in the video because it's important to see that you can always go back and fix what you did. There is absolutely no shame in mistakes. It's how we learn. I tell you that all the time in class. All right, so 3 times 4 is 12. 2 times 0 is 0. Add these up, you get 12. Now 0, 5. We have 3 times 0 plus 2 times 5. So this would be 0 plus 10 equals 10. That one's not it, that one's not it. Let's test this last point. So 3 comma 2. We have 3 times 3 plus 2 times 2. So we have 9 plus 4, which is equal to 13. That one is our maximum value. So we would want to make 3 trays of corn muffins and 2 trays of bran muffins to maximize the amount of money that we can make based on the ingredients that we have available to make them. And that is the answer to the question. 3 trays of corn muffins and 2 trays of bran muffins. All right. And there you go. Now you can see everything that I wrote. And I hope this example helps. And look for more videos coming out from me very shortly. I'm planning on doing a video showing you how to graph linear inequalities, in case that's something that has been tripping all of you up, and if it's a review that you are needing. Okay. I'll see you again soon.